Hello everyone, so in this video, let's talk about a medium level problem from LeetCode. The problem name is add one row to tree. So let's start. You are given a root of a binary tree and two integers val and depth. Now add a row of node with the value val at the given depth, which is depth that is given to you. So you just have to add a row, as you can see, with the given value. So as you can see, this is the tree that is given to you. Now you have to add a node, or not a node, a row of nodes such that it has all the value equal to 1 and it is of depth 2. Okay, similarly, as you can see here, uh, like a row of val 1 and depth 3. So let's first understand how will you add it, and then you write on the code, because then it turns out to be very simple if you understand the code, like the logic part of it. So what you'll actually have to see here is that, let's say you are given a depth equal to 2. So let's say you are on this node. You have to keep a depth count. Let's say the depth count is equal to 1 at this point. Now if you go both ways to the left and right, if I just change the color as well, if I go to left and right, the depth will increase. So which means that now if I go to left, the depth will become from 1 to 2, and that is the depth I want. So if the depth I want is 2, what I'll do is that whenever I reach this depth, I'll make a new node in whatever direction I am. Let's say I make this node, and whatever is the node below it, I'll just attach to this node. Now if I'm going to the left part, I'll attach the subtree to the left. If I'm going to the right part, whatever is the subtree to the right side of it, I will attach it. Okay, that's the overall logic that you will require. Now let's say the depth is equal to 1. Okay, which means that, let's say you have the tree like this only. Let's take this as a tree, and you want to attach a node which is at the depth equal to 1, which means that on top of this node, like this is where the first layer is, where the actual row will attach. So as you can see, this is the thing, that if depth equal to 1, that means there is no depth minus 1 at all. That creates a tree node with the value val at the new node in the whole original tree, and the original tree is the left, new roots left, which means that if you have to have a depth equal to 1, then the whole tree should be at the new roots left side. So that will become, this tree will become like this, that if I just delete it out, there will be a new node like this of, let's say, value 1, and the whole subtree will be on the left side of it, because the original tree is the new roots left. So the original tree is the new root, because this becomes the new root because this is at the depth 1. So which means that this should be the very first node now, and if it is at depth 1, then the whole tree will be at the left. If let's say it should be at depth 2, which means that it should be like this. So I should iterate from the top node until I reach depth minus 1. Okay, so let's say this is at depth 1, so I should go to, let's say, depth minus 1. So if we have to put it at depth 2, so I should go to depth 1, which is like I am here itself, and then add the two nodes to the left and right, or like whatever nodes we have, and then the subtree should be attached. Like if it's the left tree, attached to the left; if it's the right, attached to the right. Okay, that's the overall thing that you have to do, nothing else here. Okay, let's talk about the code part now. It becomes a little bit simple after this whole explanation. So what we have done is that this is the calling function. If I just expand it more, so as you can see, this is the calling function, or the main function that will be called for this particular function to run. Add one row. If depth equal to 1, which means that we on the top, that we have to just add a new node, and the original root should be towards the left of it. What is this particular syntax is? If you just go on top of it, you can see that to initialize a new node, you have three syntax. Either you can create like this, which will create a value 0 tree node, left and right both equal to null. If you put a value, then it will make a value equal to this and left and right equal to null. But if you provide a value left and right, it will create a tree node with value equal to this, left equal to this, and right equal to this. So we just want that left equal to the whole tree and right equal to null. Okay, that's why we use the third syntax here to create the new node. So if I go to the main function here again, you can see here that we have created a new node in which the root, the actual tree root, is now on the left part, the right equal to null, and we just return this particular new tree. Else we have to call this helper function with now depth, which is the depth given to you, the depth at which like the depth we start with, that is the one that we start with 1, the depth function we want at which we want to make the row at the value, and the root, return the root. We call this helper function. Let's see the helper function in explanation part. So it's a recursive function. We are doing just a traversal of it. So what you can see here is that it's a recursive traversal over this tree. So what we'll do is that in recursive traversal we have a base condition and the actual condition. So the recursive condition is that go to left and right, okay, and that is what we are going. And when we are going to left and right, what you can see here is the depth is the path, the value, we are going to left and right, and the current depth plus 1, because whatever depth we are, we're going to depth plus 1. Now whenever we reach current depth minus 1, which means that I have told you that I want to reach at depth 2, so whenever I reach depth 1, at that point I will make 2 nodes like this. Okay, so that we are trying to do here is that if I reach depth minus 1, that what we'll do is that we have to now create 2 nodes left and right, and we insert these 2 nodes such that now the left has another node and the right also has another node, given that the subtree below that, such that this is left, so the new node will be created at the value, and the subtree below it will be at the left side, and right is null. And when you are creating a node at the right of this, the right will have the right subtree, like the node pointed towards the right, like the edge coming out of the right thing will have the subtree that is on the right node, and the left is done. Okay, that's what I've told you in the logic part, and that is how you will create a row in that particular tree, and then return the new like the whole tree with this particular row. Okay, that's a complete logic. It's just an O of n traversal over the whole tree. Nothing much, just recursive traversal, and that's a complete logic and the code part for this particular problem. If you still have any doubts, you can mention in the comment box for this particular video. I will see you in the next one. Keep coding and bye.